Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we're going to learn to solve logarithmic equations. Now, one thing before we get started, these equations can have extraneous solutions, solutions that work for the equation we end up with but don't work in the original equation. And the check is actually pretty easy. The thing to remember is that when you have a logarithm of some expression, that argument has to be positive. So when we get our solution and we substitute it back into the original equation, we have to make sure that that argument is positive. We have three equations to solve here. The first two are similar. You want to isolate the logarithm, you want to convert it to exponential form, and then you want to solve what you have. So here in the first one, 4 times log base x, 4 times the common logarithm of x equals 10. The first thing I can do is divide both sides by 4 to isolate the logarithm. Log of x equals 10 divided by 4, or 5/2. You could write that as 2.5 if you wanted to, because it works out to be exactly 2.5. Now I need to change this to exponential form. And the trick here to remember is with the common logarithm, the base is 10. So I'm going to raise 10 to the 5/2 power and set it equal to the argument. 10 to the 5/2 power equals x. That's the exact solution. We can get the approximate solution using our calculator. 10 exponent, and in parentheses, I'm going to type 5 divided by 2. And on the right-hand side, we see we've got 316.2277. I'm going to round that to 3 places, 316.228. Now, I'm not going to do the exact check on all of these, but I will on this one. But first, when 316.228 goes in for x, that's the logarithm of a positive number. So that part's okay. Let's see if the numbers work out. So for the check, I've got 4 times the common log of 316.228, and I want to see if that equals 10. Let's go back to the calculator. 4 times function, and this time it was the common logarithm, so I just typed log, and then back to the main, 316.228. Is that close to 10? That is close to 10. It's 10.00000129. Really close to 10. And the reason it's not exactly 10 is that we rounded this number, which was rounded to begin with, to 6 decimal places anyway. All right, so I know that solution's good. Let's move on to the second one. This time the logarithm is already isolated. I've got logarithm equal to a number. I want to change that to exponential form. So I'm going to raise the base on the left to the power on the right. 4 squared equals x squared minus 9. 16 equals x squared minus 9. Now I've just got a quadratic equation, and this time I can isolate the x squared and solve by taking square roots. So if I add 9 to both sides, 25 equals x squared. I can take the square root of both sides, square root of 25, square root of x squared. But remember, when we take the square root of both sides, on the side with the constant, we want to take both the positive and negative square roots. We know the square root of 25 is 5. So x equals plus or minus 5, x equals negative 5, or x equals 5. We do want to check to make sure that our argument of the logarithm in the original equation is positive. I'm going to check the 5 first. 5 squared minus 9 is 25 minus 9, or 16. That is positive. So we're good there. Negative 5 would be the same thing, because negative 5 squared is also 25. So both of these check, and these are both solutions. Now the last one has a couple of things that are different about it. First, we don't have a logarithm equal to a number. We can't isolate a logarithm, and that's okay. We can also solve equations where we have one logarithm equals another logarithm. And the property we're going to use here is the one-to-one property of logarithms. If log base b of x equals log base b of y, then the only way that can be true is if x is equal to y. So if we have two logarithms equal to each other, the two arguments have to be equal as well, and that will be our new equation. Also on the left-hand side, we haven't seen this yet, but we have two logarithms that we can combine. We're going to use this rule that says log base b of x plus log base b of y equals log base b of their product, x times y. So here, I can multiply x by x plus 6, and that becomes ln of x squared plus 6x, and that is equal to ln of 16. I've got a logarithm on the left equal to a logarithm of the same base on the right. The arguments must be equal, and that means that x squared plus 6x has to equal 16. We've just gone back from chapter 4 to chapter 1, right? We've got a quadratic equation, and we know how to solve this one. Bring the 16 over to get it into the right form. X squared plus 6x minus 16 equals 0. We could try completing the square. We could use quadratic formula, but this one factors. Always look for that. This one factors to be x plus 8 times x minus 2, still equal to 0. And our two potential solutions are going to be negative 8 and positive 2. Now we have to make sure that the logarithms in the original equation are okay. So let's do a check down here. And I'm going to start with negative 8. Put in negative 8 for x in the original equation. Natural log of negative 8 plus natural log of negative 8 plus 6 equals natural log of 16. Those two arguments are not positive. Negative 8 is negative. Negative 8 plus 6 is negative 2, also negative. This solution is what we call extraneous. It was a solution to that equation. It's just not a solution to the original equation. And to make matters even worse, it's a solution to this equation. So if you plugged in negative 8 on that left-hand side, you would get the natural log of 16. So it works there, but that wasn't the original equation. The original equation had those two logarithms separated, and the problem here is that negative 8 times negative 2 is positive 16. So we had numbers that worked, but not in the domain of that function. If we check x equals 2, we're going to have natural log of 2 plus natural log of 8 equals natural log of 16, positive, positive. All right, those are a few logarithmic equations. We'll come back and do some more in the next video.